Hi guys, in this video we are going to work with mathematics paper 2 grade 12 senior certificate examination or national senior certificate examination, right? Specifically today we are going to look at trigonometry. For those of you who are preparing the examination that will be written on Monday, I hope this video will help you on how to tackle tedious questions. Specifically, we're going to look at trigonometry. Right, let's see which question are we going to focus on. We are specifically going to look at question 5 in this case. We're going to look at question 5, as you can see from here. In the diagram, P is negative 7 on 4. It's a point on a Cartesian plane, and R is a point on the positive axis such that the obtuse, okay, R is the point on positive axis such that obtuse PQ or R is equals to theta. Then first question says calculate without using a calculator. So meaning that there are certain methods that we should use. Then without wasting time, let's get to today's video. So we are required to calculate the length of OP. Guys, what we could see that this forms a right triangle, right? So there's a missing part. We have x and y. Your x is your adjacent, your y it's your opposite. Then the missing part, which is OP, will be r, the hypotenuse. So we are going to use the theorem of Pythagoras to calculate the length of OP. Let's put this into practice. So we are at question 5. So this will be 5.1 and 5.1.1. Okay. So what will happen here? Since we are looking for OP, so we'll make OP the subject. It will be OP squared, which is equals to, remember that your P is given as negative 7 and 4. So this will be your X and this will be your Y. So you're going to have negative 7 squared there plus 4 squared in this case. So what is 7 squared? 7 squared, guys, it's the same as having 49. It's the same as having 49. Okay, then what is this will be positive 49. So what is 4 squared? 4 squared there will be 16. Then we have OP. We have OP squared there. Then what is 49 plus 16? 49 plus 16, guess it will be 65. Yes, it will be 65. Square root of P will be square root of OP, it's OP. Square root of 65, it will be root 65. We're going to take only the one that is positive because the hypotenuse can never be negative. The hypotenuse can never be negative, right? Okay, let's go to 5.1.2. At 5.1.2, we are required to calculate the value of tan theta. Yes, so they are looking for tan theta. Let's see how we can get tan theta. Remember, this is 5.1.2. So to get the value of tan theta, guys, it's the same as having opposite all over adjacent. So y all over x in this case. So remember, this is what is your y there? Your y it's 4. What is your x? Your x it's negative 7. So you're going to have negative 4 all over 7 in this case. Okay. Then 1 mark for saying that. Then let's go to 5.2. Let's see what 5.2 want us to do. So at 5.2, determine the general solution of sine cos x plus 3 sine x is equals to 3 cos squared x plus 3 cos x. That's 7 marks, guys. You can't afford to lose such 7 marks. All right, so, without wasting time, let's also put this into practice. First thing, we are given 3, we're given sine x as well as cos x plus sine x equated to 3 cos squared x plus 3 cos x. Right. The best way of solving this is to make it right. Put it in the standard form first before we do anything. So we have sine cos x plus sine x. Let's take this part to the left hand side. So it will change the sign. Negative 3 cos squared x plus 3 plus minus. Sorry for that. Plus minus 3 cos x. Since it's a quadratic, you equate it to 0. So we can see that there's a highest common factor in this case. So even here, we can take out the highest common factor, which is sine x. Then now let's factorize. So we will be left with cos x here. Sine times cos, it will be sine cos x. Then to get to sine x, we need 1. Okay. Similarly, in this case, we will need to take out the highest common factor. If we can take negative 3 cos x, to get to cos squared x, we need cos x. So to get to negative 3 cos x, we need plus 1 in this case. So equated to 0. So from here, we can see this is a form of this type of factorization that will happen here. It's what we call grouping. Yes, so we are going to factorize this using a grouping method, right? So how do we group? Because we have common factors, common bracket, only take 1 here. So in this case, you're going to have cos x plus 1. You only take 1 bracket since they are common. Then let's sine x minus 3 cos x. We are grouping, remember, equated to 0. So this will be cos x equals to negative 1. So what about this? Let's fix this. This is the same as saying sine x, take negative 3 cos x to the other side. It becomes cos x. Then we can divide both sides by cos so that it becomes a quotient identity, cos x. So this and this cancels. So I'll have to tan x is equals to 3. Then now we need to find what we need to find now. It's the reference angle. The reference angle. So you can just say sine cos. When you say sine cos negative 1, what are we going to have? We're going to have 180. This will be 180. Even if you have put the positive value, let's see, when you put the positive value, you're going to have 0. So where is tan positive? On the second quadrant. Negative, it's on the second quadrant. So when you say 180 minus 0, you're still gonna get 180 in this case, meaning that will be the solution. So you're going to have x is equals to 180 plus k times 316. So what about this one? Let's work out this part. Shift tan 3 correct to 2 decimal places. Let's leave our solutions correct to 2 decimal places, meaning that it will be 71. X will be equal to 71 all over 71, I mean, comma 57. Okay, so this happens when k is an element of integers. So that's how you can work out 5.2. So guys, let's go to the other remaining questions. The other remaining questions, we are given an identity, which is sine 3x all over 1 minus cos x, which is equals to 1 plus 3 cos x divided by sine 3x. So we have to prove the identity above. Then 5.3.2, we need to determine the value of x. In the interval, x is an element of 0, for which the denominator will be undefined, right? Without wasting time, let's put this into practice. Okay, so actually you're looking at 5.3. In this video, this will be our last questions. We have sine 3x divided by 1 minus cos 3x, which is equals to 1 plus cos 3x. So you will choose a side that will be that is appropriate to use. In this case, I'll choose the left hand side. So we have sine 3x all over 1 minus cos 3x. So since there's nothing that we can change here, we can multiply out by the conjugate of this, the partner of this. Remember, the conjugate of this, of 1 minus cos 3x, it's 1 plus 3 cos x. So we are going to multiply the numerator as well as the denominator by 1 plus cos 3x in this case. So we are going to have sine 3x as well as cos 1 plus cos 3x. So similarly, so when you multiply this, what is 1 times 1? This is going to be 1. Cos times cos 3x times cos 3x, this will be cos squared 3x. Okay, so that we are going to, that's what we are going to have. So to make life easy, let's continue here. So from here we can see that 1 minus cos squared 3x is an identity, the square identity. So we are going to have, so in other words, we are going to have sine 3x as well as, remember that we have 1 plus cos 3x, the denominator, the numerator. This is cos, okay, this will be cos 3x, remember, and this will change to sine squared 3x. This 1 minus cos squared 3x will change to sine squared 3x. So in other words, this and this, they cancel. We are only left now with 1 plus cos 3x, which is this. We also have proof. We did proof. Here we only left with 1 of sine 3x in this case. So you are going to be left with sine 3x. So already you have proven that the left hand side is equals to the right hand side. Yes, we can see from here. What happens here is that what changes was the square identity, which is 1 minus cos squared 3x to sine squared 3x. Because we have common brackets, sine 3x and 3x cancels each other. We are left with 1 here. So we're going to put one of these, which is sine 3x. Then remember that we are left with 1 plus cos 3x. Then that's how you can get that 3 marks. Okay, then let's go to the last question. The last question is to determine the value of x, right, in the interval 0 is to 60, for which the identity will be undefined. Actually, in this case, it will be an undefined at the numerator and as well as here. Okay, at the denominator and the numerator in this case. Okay, let's put that into practice. So when it is we said that it will be undefined when it's sine. Remember, this is 5.3.2, and that one that we were doing here was 5.3.1. okay, so it will be undefined when this is 0. So meaning that our solution will lie at x is equals to 0, or when 3x is equals to 180, which is the same as having 60 degrees in this case. Similarly, even if we use 1 minus cos 3x is equals to 0, the solutions will lie when similarly it will lie when 3x is equals to 0. So because we know that this will be x is equals to 0, or when we can say when 3x also is equals to 316, and we know that this, so okay, in this case, so 360 divided by 3, that will be 120 in this case, but let's not that will be 120 in this case, but our restriction was saying that the interval will be the values of x, the interval should be 0 and 360, so we'll focus on this actually, and this as our solutions in this case, as our solution in this case. So that's how it should be, guys. That's how it should be. Don't forget to like the video, comment, and if you're new to this channel, what are you waiting for? Subscribe. Yes, we are growing. Then wish you all the best. So we'll see you on the continuity of our video, because it doesn't end here. I'll post another video also about trig, right? Okay, this is how it should be. We love you.